All right, we will start. So hello, everybody. Welcome to the Mqtt Edge adventure. I'm Kate Cahey. I'm the PI of the Chameleon project. And I would like to start with just a few words before we begin the actual webinar. So this is a milestone for us. Edge computing is something that our users frequently experiment with and have been asking for access to edge devices for a while. But this put us in a sort of chicken and egg situation, right? On one hand, we want to test bed. On the other hand, what should that test bed be like, right? So the edge computing is a rapidly developing area, and it's not clear what capabilities exactly it should provide, right? So we want a test bed where we don't know what that test bed would be. So the approach we decided on is to create a straw man, and this is what the webinar is going to be about today. So create something that we could create quickly, though perhaps not necessarily easily. And that something is allowing users to deploy Docker containers on edge devices, right? So many edge devices are not server class, they have no IPMI. It's very hard to do bare metal configuration as we normally do on Chameleon. But on the other hand, it also allows users to relatively easily add their own devices. So ultimately, we would like to have an offering that allows everybody or anybody anywhere in the world to add their own device in such a way that they can share it with their class, with their students, with their collaborators, their community, share some interesting data that they have access to, and so forth. And then, of course, those devices would be connected to a relatively powerful test bed. So you can get interesting data from your edge device and then use our machine learning capabilities to process that data. In terms of implementation, we came up with something that is based on OpenStack, like everything else in Chameleon. But we have adapted it to edge devices. So OpenStack had an implementation of using containers instead of either virtual machines or bare metal configuration, and we adapted that to use it on edge devices. So we've got something that is relatively reliable, right, when it's OpenStack, and it's also consistent with Chameleon. So you get access via federated identity, you get resource discovery, allocation, reconfiguration via containers, and integration with Jupyter. And of course, this is the first webinar in the series. Later on this month, and Jason will talk about it, we're going to have another two, which are going to be a little bit more featureful. So the features are going to be developing during the summer. Ultimately, we're hoping to give you an SDK that will allow you to add your own device. 2 points to emphasize, though. First of all, again, this is a straw man. So we're counting on you to give us feedback and to share your ideas of what an edge testbed should be, right? So are we barking up the wrong tree with those containers and so forth, right? Maybe we should be doing it differently. Or maybe this is like 80% there, right? There's just 20% missing that would enable you to run really interesting experiments. So this summer, we're going to be working with multiple groups in research, education, and applications. So the 3 types of research, types of science that Chameleon supports. And then at the end of the summer, we're planning to have a workshop, a showcase, where everybody can share what they did on Chameleon, on Mqtt Edge, and how that worked out for them, right? And also everybody can look at anybody else's stuff and say, hey, you know, this is interesting. They're teaching classes in this way. Maybe I can borrow their educational materials, adapt it to my area or to what I'm doing. So that's one point. We're really counting on you to work with us and then have a nice, have a lot of fun this summer, right? And then have a nice discussion at the end of it. And of course, we're planning to invite NSF as well. So they also need to know what capabilities are possible for working on the edge and things like that. And then the second point I wanted to make is that what you will see, it looks implementation complete, but it's probably 10% of the work that will need to be done to make this really solid, to make it scale, to deal with various malicious device corner cases. I mean, we thought this through, so we know what approaches there are, but they still need to be implemented. To deal with various networking corner cases and various networking issues, make that efficient. And this is a place where we would like to work with you as well, right? So when you're thinking about experiments that you can run, think bold, think ambitious, right? Run interesting experiments, and perhaps we can collaborate together on introducing some capabilities to the infrastructure. Okay, so with that, I would like to pass the baton to Jason Anderson, who will describe the main implementer of the Mqtt infrastructure and will tell you how to use it.
Cool. Thank you for the introduction. Just going to do the old screen share switcheroo. There we go. Okay. Now's the time when I ask everybody if they can see my screen. Seems like it's loading now. There we go. Okay. Thanks for the intro again, and thank everybody for joining us today for the sort of introduction early preview webinar for Mqtt. Again, my name is Jason. I serve as a DevOps lead for Chameleon. And yeah, the team here has been working on building sort of the prototype strawman, as Kate said, of what we're calling Mqtt. So, I mean, just a really quick, for people who maybe aren't as familiar with what Chameleon is, Kate sort of already addressed this, but we are a platform that offers, as a cloud offering, a sort of research infrastructure for computer science and information science, engineering, etc. experiments. So we provide some things that a lot of other clouds don't provide, such as we really focus on really deep reconfigurability at the bare metal, performance isolation, you get the entire machine, you can bring custom kernel, etc. And we have a lot of diverse hardware that we've bought and integrated and maintain as part of this. And we're constantly upgrading that over time. And kind of one of the sort of interesting aspects of Chameleon in particular is that it's built on commodity open source infrastructure, namely OpenStack and some other sort of special things that we do. Just by the numbers, Chameleon's been around for quite some time. We just got renewed for phase 3 last year. We've got 3 more years to grow and build and serve the research community. So far, we've served over 5,500 users in 45 countries. And they've done a lot of work on the testbed, which is always very exciting. One of the main things that Chameleon, one of the challenges that we have, though, is we're always chasing the research frontier. So whenever there's new capabilities or new emerging sort of problems, we're always trying to be there with support for that type of research. And so in the past, yes, we've supported research in lots of aspects of computer science, system storage, networking, AI, we have a lot of, that's been more of a focus. We bought lots of GPUs, integrated them. But now edge computing is really cracking open a lot of interesting problem domains and research areas for all of the above. And the cool thing is, though, the edge devices are really cheap and customizable for the most part. And so on one hand, you could just look at this and be like, great, everybody just go out and buy your things and buy your drones and attach them to stuff and put the sensor here, and then we're done. And actually, Chameleon, there's no reason for Chameleon to exist in this world. It's very democratic. However, in reality, there are some issues that you still deal with when you're working on the edge. Some of them are very familiar, like you've got to figure out how I have all these devices, how do I connect them to my network securely? How do I enable access for myself remotely in a practical way? Because I'm going to need to be able to debug this stuff. How do we manage the fact that we want to maybe share a device among multiple people? How does that get coordinated? And what if we want to share the entire device with a different group? Or if somebody else wants to use my drone to run some custom codes, how do we get access? How do we revoke it? All the times it's just done on a very ad hoc basis. And it's sort of a lot of operational challenges that then get democratically pushed to the edge, to the edge researchers who have bought the devices. Also some novel challenges, at least from the data center perspective, of if you're going to be obtaining these things and providing them to groups. We've got really remote locations. They're no longer in a sort of air-conditioned room that you can easily get access to. Very unique difficult power networking constraints. Devices can be offline for days at a time. They're small, they're weird, they move. It's just a lot of things that you have to deal with. So what we're trying to answer with Mqtt Edge is, or rather, what we're, the questions that we're struggling with are, like, what capabilities does a test bed like this require? And again, this is where I think we kind of look to the community for input on that. And second is, can we build such a test bed with commodity open source software? And so that's what we're trying to do with Mqtt Edge, and we're going to show some of that today. So to sort of make it a bit more clear, like what exactly we're talking about. So Mqtt Edge is not, it's not this. We're not like taking edge devices, sort of plugging them into server racks and making them available in a similar way as we would do with bare metal hardware. Mqtt Edge is more about this. This is a Raspberry Pi cluster that I built here on this table behind me. And this was a picture of it on my apartment floor. So it's about bringing the platform to the edge where the devices are, rather than bringing the devices into the data center where the platform is running. Another example, this is from a colleague, Mike. This is his cluster of a few Raspberry Pis with the dinosaur added for scale. And but interestingly, it's connected to a software-defined radio. And so this is just another example of like the type of like heterogeneous device space and possibilities that you get with the edge, and why it's also important to consider that they're, maybe where they're deployed is very important, and it's kind of important to preserve this property of edge. The last example I'll give is, part of the point of Mqtt Edge is to kind of take these individual deployments like this and turn them into shareable instruments. So it's now no longer a set of Raspberry Pis on Mike's desk or a set of Raspberry Pis on my table. It's actually a sort of a unit that you can use to do research and to have other people do the same research on that unit, if you want to support that. As an example of that, there's like an interesting use case that we're sort of exploring with University of Chicago here locally. They've got this room in the computer science building. It's got a sandbox Wi-Fi network, and they have tons of consumer IoT devices connected to that network. And they run, they put Raspberry Pis in there as well to do network analysis, to sort of check like how much, what are the privacy issues around these consumer IoT devices? How secure are they or not? And that's the kind of resource, though, that is difficult to build, and it would be nice to turn it into a shareable instrument so other people can do such research. So that's kind of what we're trying to accommodate. Side-by-side comparison, if you've used the bare metal site before, it works very similarly. So where on bare metal, you make advanced reservations for a single machine of bare metal. On the edge, we're going to make reservations for a device or multiple devices. Instead of bare metal reconfigurability, we're going with container reconfigurability, kind of striking this balance between isolation, but also practical flexibility, being able to support a wide variety of device types. We still get single tenant isolation by virtue of the fact that you reserve the entire device. And have a very heterogeneous collection of hardware, and attached peripherals is also kind of the really interesting, cool bit about the Edge platform. A lot of the networking stuff is sort of just works the same. So you can get isolated networking. You can have two containers that, from their perspective, they're on the same, the same layer 3 network, the same subnet as another device located somewhere else via overlays. And we also have public IP capability. This is really cool because, for the Raspberry Pis in my apartment here, when I first set it up, now they're at an office, I didn't have public IP to slap on them, nor did I really want to allow incoming connections into my home network. But the platform accommodates this. It's able to work in a variety of networking environments where things like lack of public IP capability or firewalls are in play. The composable cloud APIs, you can you get that for free just by virtue of we're building on top of Chameleon's existing cloud offering. So you have graphical user interface, CLI access. I'm going to be showing Python and Jupyter interface during the demo. So a lot of you can use it similar to how you're used to using other cloud platforms, I guess I can say. But one of the most interesting differences is with the ownership model, where before Chameleon was, we were using some of the grant money to purchase hardware that was interesting for the community, install it, integrate it, operate it, maintain it, all internally, with the help of our host institutions. On the edge, we're interested in more of a mixed ownership model where, yes, we are kind of purchasing some devices ourselves because we think they're cool and we want to, provide some of them to people who do not have devices. But we're really interested in this idea of bringing your own device to this platform, turning those into shareable instruments, but also just allowing you to just connect your existing edge devices to experimental networks that are existing already on Chameleon. So you could, for example, just connect the Raspberry Pi to your Chameleon GPU node and do some interesting edge cloud split experiments. So we're kind of trying to tackle this from a lot of different angles. But yeah, let's just take a look now at what we have before we get too excited. And yeah, I'll sort of show what we've got. So for the demo, I'm going to use a Chameleon's Jupyter integration. And there's an existing webinar we've already done on the Chameleon Jupyter integration, so I'm not going to go over it in like massive detail, but I would say that it's something that we're quite interested in developing and making, improving over time. The cool thing about it is that we've integrated this Jupyter environment with the Chameleon testbed, so you can call out to invoke these cloud APIs to ask it to do things like reserve an instance, reserve a bare metal node, launch an instance, create a network. And now we're extending that to allow us to do the same thing, but with the edge platform where we're working with containers instead of bare metal instances. And one of the nice side effects of this is that it's really easy to like show somebody some work, and it's also good to sort of have documentation for yourself later where you can come back and redo an experiment. So let's get going. Oops. So the first thing, the demo is going to be in two parts. First part, we're going to sort of do a general overview of the capabilities, and then we're going to stitch together those capabilities to make something that's a little bit more real, like using a Mqtt experiment with a few containers. So first things first, going to select that I'm going to use the new edge site, which it actually is available now. I would kindly ask that anybody on the webinar please refrain from poking around too much, just for my own sanity while I'm doing this. I'm already fighting the law of demos here. So, but it does exist, and I'm just going to say like it works very similarly to other Chameleon sites in terms of how you get around if you've used those. But yes. Now, I'm going to sort of, choose the project I'm going to work on, so the internal project that we use for Chameleon. And most of what I'm going to do is just using Chameleon's Python API called Python G for Chameleon infrastructure. And we're going to use a set of functions that we've developed to make it easy to interact with the Edge platform. So the first things first, we're just going to, just jump into it and launch a container. Now, if you've worked with Docker before, this is going to look really familiar. The API it translates almost one-to-one. So we're going to be creating a container. We can pass it a sort of name, image. We can pass environment variables. We can ask what ports to expose, and if it starts automatically when we launch it. And I'm going to create one. It's just going to be my first container. I know that I'm deploying to a Raspberry Pi, which has an ARM architecture, so I need to make sure to pick one that has support for ARM 64-bit, but I have one. And I'm going to make it start up a Python server serving from its working directory, which is this. And also, I'm going to ask it to expose this port, which normally any container will have all ports firewalled. And exposing the ports, you allow, say, which ones you want to allow access to. So I'm going to run this. what it's doing now is it's sort of scheduling a container on one of the, in this case, we just have a homogeneous pool of Raspberry Pis enrolled in the Edge platform right now. So it's finding one, it's asking for it to start the container. It's pretty fast, especially if the image is already cached on the Pi. If it is not cached on the Pi, it has to download it, and so it'll take a little bit of extra time to do that. But this one, I've already run this, so it was already there, so it was pretty quick. It's there. So the container is now running, and I can verify this by you can run one-off commands, which is good for a little sort of debugging, sanity checks, and I'll do that right now. So it's just ran this command on this Pi, which again is in that UChicago office, just a few blocks away from me. So Jupyter is sending this command, it's sending it to the system sending it to the Pi, and all the results are kind of being piped back. Okay, so there's nothing in that folder. It's sort of not that interesting, but expected. But now, I'm going to actually attach a public IP address, and it did. And now I can go to that address, and I can actually see the output of the web server, which it's serving nothing, so there's nothing there. But I'm able to route over the public internet to that edge device that itself doesn't have a public IP address. It's the platform is taking care of this for us. Okay, so now I'm going to upload a file to that container, so it's actually going to serve something. And this is kind of cool because we can actually upload files directly from Jupyter. So I've got this this web server folder running here that has files that I'm going to be serving. And in particular, I've got this one little HTML file that just is sort of like a hello world. Yep, it is. And I'm going to upload this to the container, to that folder that it's going to be serving. So that's done pretty quick. Now, if I reload the server, I can see that indeed that file is there. And I can even, if I want to, in Jupyter, I can edit this file. I can add another tag if I can type. And let's just upload that again. And now if I reload, I see that it's just gotten updated. So this is a really nice workflow. You can keep everything in Jupyter, and you can just sort of send it directly to the container. That's one method of configuring your device. And yeah, you can manage the container lifecycle as well. When you're done, you can spin it down, which is what I'll do, and that will also release the public IP address for use by another container. Very cool. So that's going over like a mixture of just general launching container and what you can do with it, some options you have for configuring. But now I'm going to show a few more of these things combined in something approaching a real experiment. But it's pretty simple still. This time we have two containers. And one of them is going to serve as an MQTT, which I think is like message queuing transport, something. I shouldn't have tried to remember what the abbreviation is, but it's just a message broker. It's very popular in IoT experimentation, pretty lightweight. It's often can be used to deploy one of these on the edge, and it serves as kind of like a little pub sub mechanism to send messages back and forth between devices. So we're going to spin up one. We're going to spin up a publisher as well, which will then publish to a topic on that MQTT server. And then we're going to connect this Jupyter notebook over the internet to the MQTT server to sort of listen on events, and we'll sort of stream them in real time to a graph. That's the goal, at least. So I'm going to just sort of start this running in the background while I explain what's going on. So this is a bit more of a complicated invocation of creating a container, but it's not that different than what we did before. It's using a different image. In this case, I'm using a Mosquito image, which it's an implementation of the MQTT broker. it needs to expose one port for Mqtt and one port for WebSocket support, which we're not really going to use in this demo, but just showing you can expose multiple ports. And most importantly, we're going to be passing a configuration file that's going to sort of mount at start time. And this is an important capability because this is, if you've used containers before, this is often how you sort of configure a container at runtime. The container is set up to look for a file at a certain location, but overall it's kind of static, and it will just read most of its configuration from a file that you can then mount inside the container, and then it reads that, and you can change that file. That's how you can have one image behaving differently depending on different configurations. The cool part about this is, again, we can do this all from Jupyter. I've got a Mqtt configuration here, which is allowing anybody to access, which you don't want to do in an actual experiment, I feel like I should point out. But for the purposes of this demo, we're going to just do that for simplicity. And it's going to start up that server with that configuration, which is sort of read from Jupyter, and we're just sending like the file with the request, and then it will be mounted onto the container at start. And that container has started. It got its own private IP on the network that it was launched on. By default, all these containers launch on a kind of a shared network, similar to SharedNet if you've used Chameleon already. So it got its address. It's all good. Now we're going to start the publisher. And the publisher is doing a lot of similar stuff. But we're going to be taking this script, which is another file. And this is going to be the startup scripts. This is the script that runs when the container runs. And what it's going to do is contact a Mqtt host at this address, configured by an environment variable. And it's just going to publish some like random number according to what awk thinks random numbers are every so often to a topic that we define. So it's just basically just spitting out some data every so often. And so we're going to mount that into the container so that I can find it and use it. We can actually use the same Docker image as before because it has both a client and server component come in with this image. And we're just changing the default command. So by default, we didn't override, we didn't specify a command before because it just uses the default one defined in the image, which is to start a Mqtt server. In this case, we want to start a different process. And so what we're doing is we're mounting that script, and then we're telling it, run that script as the process instead of what you would normally do. And yeah, I'm also able to pass in some parameters into that script that I can set in my notebook. So I can actually kind of tweak everything here. And then it sort of, when the container gets run, it takes in those parameters as part of its behavior. Okay, so that has started now. So at this point, we've got two containers running, and one of them should be sending messages to the other. But now we need to connect to it from Jupyter. And my Jupyter server, the Jupyter environment is external to any of the private networking that like these containers are talking to each other on their private network, but Jupyter doesn't have access to that. We need to actually go over the internet to get there. So I need to attach a public IP to the server, which I did. And now I'm using a Python Mqtt client, which is pretty simple. I'm just creating the client, connecting it to that address, and then I'm going to tell it to listen on that topic that it should be publishing events on. Okay, and now is the last thing. So now I'm going to start basically listening for messages on that broker on that topic. I'm going to listen for a few times for data, and as we get data, going to update a plot that is going to be rendered to Jupyter. And so we can see that it's pulled in all the data that's already sort of written to the broker, and now it's listening for new data that's coming in. And so we're getting kind of this real-time view. So that container is poking messages into the queue, and then those messages are being peeled off and displayed in a graph in Jupyter. And as you can see, Awk's idea of random is a little bit strange. This is, yeah, anyway, but that's just sort of showing you general bit of like what kinds of things are possible today with what we have. It's pretty easy to spin up containers to manage their life cycle. We have multiple ways of configuring their runtime environment and configuration. You've got public IP capabilities, you've got isolated networking, and there's some other stuff I didn't show that we're kind of playing around with, notably persistent volumes. So being able to sort of mount a persistent volume to a container and then have that, when the container exits, you can still take that data and reattach it later to another container or something. Yeah, and I'm just going to clean up those two containers. And let's jump back into presentation. Just got one or two more slides here. So to talk about, so I just sort of showed like what we have today, and this is a general roadmap of like where we're thinking that this is going, and so on the near horizon. And it's a kind of a near horizon timeline because, as we said, like we're really anxious to get more information about your requirements. Is this straw man useful? Is a different direction needed? Do we need to build in this area or that area? Whatever. But today we have early preview availability. You can log in with your federated identity, just like any other Chameleon site. We support reconfigurable networking and public IPs. You've got this a variety of interfaces available, similar to other testbeds that testbed sites that are operated by Chameleon. We have a homogeneous device pool right now. We just have Raspberry Pi 4s with 8 gig memory, and I don't know, I think 32 gig like disk or SD space. And we do not have single tenant isolation yet, but later this month, we're going to be building support for advanced reservations. So you can reserve an entire device, at which point you will get that single tenant isolation. As part of that, we'll have an availability calendar where you can see the availability of resources, like how many are available, and also we show like for an individual device, like when is it reserved, because you might actually care about getting a specific device because they're all going to have interesting properties that are relatively unique. We're going to be extending the pool at this point and have more heterogeneous devices. We're looking at NVIDIA Jetson and looking at some sensors like that SDR that I showed. And then by the end of the summer, we're going to be more interested in expanding sensor and peripheral integration, or just basically just trying to go as wide as possible with the types of devices that are on the platform for use. And as that happens, it's going to be more important to have a browsable device catalog so you can see what's on the platform, what properties it has, what's interesting about it. So that's coming at the same time. But notably at the end, we're also aiming to announce a private beta of bring your own device. So allowing you to contribute your device in one of two ways. And the first way is when it's like a trusted device, which means it's actually part of the sort of edge platform as a first-class citizen. So other people can reserve it. They can launch containers and workloads on it. And this really makes it into a shareable instrument. It's pretty cool. It does come with like a few security requirements and SLAs. Like they should be available, for use for some amount of time. Otherwise, it's not really a shareable instrument. And we want to make sure that we are able to deal with any possible sort of like minimize security risk, basically, of having additional devices on the platform. Like right now, we've got devices that are kind of under our control, and we want to open that up. But we've got to want to work more with people contributing these devices. The second option is ad hoc. And this is more of like if you've got a device and you just want to connect it to an existing Chameleon environment, like you've got some experiment running on one of our other bare metal clouds and you want your Pi or your whatever device to be able to connect to that. So that's another type of bring your own device. And that's, we don't support, reconfiguring the device in this way. It's sort of on you to configure that locally, connect it to the remote environment. It also means that you sort of lose a little bit of the reproducibility aspects. Like it's harder for somebody else to reproduce your experiments, or even you to reproduce your own work at times. So there are like trade-offs basically. And I will say, again, with the trusted use case, as Kate sort of alluded to in the beginning, we're looking at how to a lot of the work with the testbed like this is figuring out how to develop models of connecting and connectivity contribution that are secure but are able to accommodate the various different deployment environments that edge devices live in. So we're looking at that. We take that pretty seriously. But for the beginning, that's why we sort of say trusted, because trust is important. Okay, and so that's the roadmap of what we've got. And yeah, like I said, or like we said, we're really interested to get your feedback. If you have not joined the Google group, there's a link here. And this is where we will announce things like as they're changing, as new capabilities are released, as new devices are released. But it's also a place that we'd like people to, interact, sort of ask questions, say, troubleshoot, share what they're doing or interested in. And with that, I'll turn it back over to Kate.
Okay, thanks, Jason, for a fabulous presentation. And we have quite a little bit of time for questions. So Isabel will read those questions off of chat. Everybody, if you haven't seen her note, please, if you have questions, put them on chat. Isabel will read them off and we'll deal with them here. The first question, will the slides be available? Yes, they will. And even the recording will be available of this webinar as well.
Yeah, great. Okay, thank you, Kate, for that introduction. So the first question that we have is, what kind of deployment environment do we currently have or envision, and what kind of peripherals?
As far as so I guess I can take a first stab at this answer, and then we might need to bring Mike in as well.
Yeah.
Currently, we're targeting the Raspberry Pi compute platform, and we're looking at NVIDIA as a second. But I think we're kind of realizing that we're going to probably need to look at something that's a bit more generic over time. And in particular, I think we're evaluating, or in really early stages, Mike, you have to correct me if Elena as like a general purpose operating system environment. But it also kind of depends on the different ways of bringing your own device. So in the sort of trusted use case, there are more limitations, and that kind of more so that's where like the platform really makes more of a difference. If you're just wanting to connect a device, I think we're aiming to have a wider compatibility because it's a more general purpose sort of ad hoc use case.
Yeah, maybe I can expand on that a little. So the basic requirements for it is just that it's able to run Docker and has a broadly compatible kernel. For the trusted case, we're really going to be kind of whitelisting platforms to approve just because there are so many edge cases. But for the bring your own device, it's really just layer 3 connectivity. So it's nearly anything that could run WireGuard will work.
Perfect. And then kind of following up, you touched on this a little bit, Jason, already, but what kind of hardware do we currently have? And then what ones do we plan to provide?
I'll let Mike answer this one as well.
Sure. So right now we've got the Raspberry Pi 4s with 8 gigs of RAM, and we're evaluating a variety of the different NVIDIA Jetson and Xavier boards. For what devices we support, it's going to be kind of a mix of what different experiments need. There are a lot of people leveraging the Jetson platform, which is why we're looking at it. And we're also going to see, are there kind of operational or reliability issues that come with certain of these platforms running at scale?
Yeah, but very importantly, Luca, I think you asked the question, but to everybody, please let us know what platforms are of interest to you. If there is a specific platform that you would like to try out, if there is a specific type of NVIDIA Nano, which has a lot of memory, for example, or is otherwise specially configured, we're very interested in those requirements. We would like to add them as soon as possible. Also, if you're in a situation where you need multiple NVIDIA Nanos, for example, like 10 of them or something like that, we're interested in those requirements as well. And then, Mike, I think you need to explain your giant antenna, right, which with the dinosaur for scale. This is a very special kind of SDR, yes?
Well, it's special because it's cheap, but so in that photo that's a RTL Sdr. So it's like a TV receiver turned into a programmable instrument. And it'll let you really just listen for kind of interesting signals in the air that happen to be around that device, and download weather satellite imagery, try to listen for which Wi-Fi channels are occupied, that sort of thing.
So we're definitely planning to provide some SDR equipped devices with receiving capabilities. Otherwise, the same comments on sensors as on devices. We're really interested in what people would like to work with.
Yeah, we're actually really flexible in terms of what sensors we're able to support or are interested in supporting. A lot of it comes down to where are we able to physically put these things. Maybe some people don't want a camera pointed at them, that sort of thing.
Okay, great. And then the next question is, do edge devices need to port Qi and all components, or will they act similar to bare metal and KVM instances that are launched and provisioned in Chameleon right now?
Yeah, so they will need to, for trusted devices, they will need to port, they'll need to have something running on them that supports their enrollment in the Chameleon Edge Cloud. But what we're working on with this as well is to have an SDK that you can use to sort of configure your edge device such that it can participate in the cloud platform. And it doesn't need to run like a lot of services. Again, like Docker, we do Open vSwitch for some of the network aspects. And so some of it is basically, the SDK will make it easier to set all of that up on the edge device. And so, yeah, that's what we're aiming to provide as well as part of the bring your own device capability.
Perfect. And then another one is kind of building off that. What are the basic requirements for the bring your own device equipment? For instance, types of connectivity needed or OS?
I think we maybe touched on this a little bit already in terms of like the OS and the connectivity aspect. I would say is, yeah, like Mike said, we're relying a lot on WireGuard technology. And so really all that you need connectivity wise is a connection to the internet. So your device needs to have NAT to the internet. And that's basically it, because they're able to then establish secure tunnels via WireGuard to the edge platform.
And then is the Jupyter tutorial already available, or how will that work?
Yeah, it's not yet available, but that's just a matter of me flipping a switch to make it public. So I will do that right after this, and maybe we'll share it out on the Edge users group so that you can play around with it.
Perfect. And then would you mind briefly explaining the inner workings of the Mqtt Edge framework from a developer's perspective? For instance, to what extent is the existing OpenStack Kubernetes integration framework leveraged?
Right. Yeah. So this is not, we opted to not do anything with Kubernetes. What this is using instead is a container orchestration engine, or really a wrapper over a container orchestration engine called Zune. It's an OpenStack project, and it basically provides a way, it sort of implements like a simple container orchestration engine where you've got multiple different hosts that can accept and run Docker containers. And then it builds a lot of APIs on top of that to do things like, manage container lifecycle, upload files, view logs, run one-off commands. And most of that is just done via the Docker daemon itself. And then for the other part, there's a library called Courier. Don't know if I'm spelling that right. That handles the networking aspects, and it basically stitches OpenStack Neutron networks to Docker containers. So it provides the glue on the device side, and then otherwise the edge device on the host is participating in an overlay network that's managed by Neutron. So Neutron manages most of the networking bits. We have this project called Courier that sits on the edge side and just sort of connects, does the last mile between that and the Docker container.
Okay, awesome. Thank you for answering that. And then another one is, are there any edge devices for us to try out? So can you maybe speak to how people can try out our edge devices?
Yeah, so right now we have a small set of Raspberry Pi 4s that are available. You cannot reserve them at the moment. That's going to be coming later this month, at which point you'll be more of a reliable self-service mechanism for actually reserving the device and using it, and not being subject to things like noisy neighbor problems or whatnot. So the short answer is yes. And it'll be improved, and you'll actually have more reliable access to them later this month.
And then another question is, can you provide?
Isabel, if I can just interject,
Yeah,
I was on mute somehow. So the key here is that yes, the devices are there, and if you remember Jason's introduction, right now they are available on a multi-tenant basis. So right now they are available on the same basis as an EC2 cloud, for example, right? You just go there and you spin up a container, and you can work in that container. And those are the same devices that Jason was showing on the slides earlier. So by all means, please do give it a whirl, try it out, start working with it. That's why they're there. And then, as Jason said, later this month, we're going to add more different devices. And once we add more different devices, we're going to make sure that they're available on a single tenancy basis. You're going to be able to point to a device, say I want a device of this type, and not just any device that is available, and use this device very similarly to how you're using Chameleon resources right now.
great. Thank you for that extra explanation, Kate. And then going to another question. So Jason, this question is a little bit about connecting what we've seen today and edge devices in general. So maybe could you give a couple examples of how people could use these edge devices and like what kind of experiments they could do with that? Yeah.
Sure. Actually, Mike, would you like to maybe take a first stab at this, because you might have a bit more experience with some of that?
Sure. So first to clarify, as it is right now, these current machines are kind of a sandbox, so they don't have sensors attached yet. But we're going to be deploying ones with sensors like that SDR, with cameras, with atmospheric sensors. And so anything where you want to collect data from something at the edge and get it dumped right into a Jupyter notebook or process it on existing cloud servers, or we're trying to kind of package the existing sorts of edge experiments you might do on your lab bench, but make it repeatable and executable through this platform.
Yeah, and just to add to this, because I see this as a question from Luca, I think whether they are in office, outside, and so forth, I think Jason addressed this earlier on, essentially anywhere where you can get on the internet in some way, via a NAT, for example, that's good enough. So it's kind of like with your laptop, right? You open your laptop, you're you could be in the office, you could be sitting on a park bench outside, and it connects to the network. If you can do that with the device, that's fine. That's all we ask for.
And I will say also that, I said that we have Raspberry Pi 4s and they've got a lot of RAM. But when we were initially building this, we also were evaluating lower power and lower capability Pis, and the platform does run on like a Raspberry Pi 3 as well. So with like 1 gig RAM, I think was the one I was trying it out on. You can't do as much with that, but you can still launch, an application or two on that thing with the platform. So there's not a huge amount of overhead that the platform imposes on at the edge. The other thing I wanted to say was, about like more examples. So we've got one interesting example we're exploring this summer that's maybe instructive, where there's a research group that we're partnering with at FIU, and they are interested in, it's more of a domain science partnership. So they're interested in how do we count fish populations in certain areas off the coast of Florida more efficiently, because this is difficult for a variety of reasons. They have an autonomous vehicle platform that's able to receive input about like where it should go next, and that vehicle also has like some cameras and stuff installed on it, and it's a bit of a pluggable framework, so you can add a Raspberry Pi to it, for example. And that's what we're looking at doing, is setting up kind of a split cloud experiment, where on the cloud end, on Chameleon's existing GPU nodes, we're running like a deep learning model that people have invented to count fish, which apparently exists, and training that model, and then having a Pi managed and kind of configured via this G8 platform. So like making it so you can kind of, ask, I'm going to reserve this Pi on this thing, and it'll probably have to be like docked when you're doing this because it can lose connectivity, but you can then ask for a container to be launched, configure it a certain way. Then the hope is that it goes out, it collects data from its camera whenever it's able to pipe information up to the GPU server, it does so. But all of this can be orchestrated effectively with like a single platform of Chameleon and with Jupyter, and have sort of more friendly interfaces. And importantly, especially now that there's a lot more remote work, it allows people to engage in this type of research remotely. They don't have to have as much physical access. Physical access will always be required, of course, but that's sort of part of the vision.
Perfect. Thank you for that example, Jason. I think that connected really well with what we've seen so far and how we can connect it and do some experiments. So that concludes all of the questions that we have in chat, unless anyone has lingering.
I think I see one from Massimo here about the connection between what we have seen and edge devices. Did we do that one yet? Did I just
I was trying to address that with like the sort of the FIU experiment use case.
Oh, okay, yeah.
Mm-hmm.
All right. Very good. Very good. Massimo confirms that that we're all good. All right. Any other questions? We appreciate all the questions, and we appreciate willingness to try things out. We rely on you to give us feedback, and like I said earlier, tell us if we're barking up the wrong tree, and how we should adjust our approach, and whether you come up with experimental or application scenarios that need something other than we provide here. And otherwise, though, if there are no questions, I think, well, let me just reiterate, come and build this testbed these capabilities with us. We would appreciate your help so much. Thanks everyone for coming. Oh, no, one more question. No. One more question from Luca. Does edge-to-edge work? Since you're using WireGuard, it might be possible to not hole punching with it.
I can take a crack at that.
Okay.
It depends, at least right now, it depends exactly what you mean by edge-to-edge. All of the devices that you have containers running on can talk to each other through the overlay network. But right now, the overlay network is kind of hairpinning through our virtual site, which is running at Chameleon. If the containers had an interface that was going from the device's own network instead of through the tunnels, they could also access things on their local network. So traffic between two edge devices at the same location on the same network could possibly work.
Yeah, and I did actually get something like that working when I was evaluating that 4-ply cluster, because they're on the same local network. And I didn't do anything sophisticated, but by just setting up different routing, I was able to effectively get edge to edge, where they were just bouncing through the local network to get to the overlay. As far, yeah, but like what you say with sort of edge to edge tunneling, it would be possible. It's not something that we've identified as something that we're going to be spending a lot of time on immediately. But if this is important to address, then we should, I guess is the answer. But yeah, it should. The underlying technology we're using, try to keep it pretty simple for this reason, and I've been pretty happy with how WireGuard has helped make this possible as well.
All right. Thanks again to everybody for coming to the webinar and for all the questions. And thank you, Jason, for a fabulous presentation. Thanks to the panel for answering the questions. We're hoping to see you on the other webinars. We're hoping to see you on the mailing list. Keep those questions coming. All right. Thanks all.